Okay, so welcome to this video. In this video what we're going to do is discuss the epidermis of the skin. Okay, so we're going to discuss the structure of the epidermis and how it is continuously renewed and shed. Okay, right. So, to start off then, we're going to start off with a basic discussion of the skin to see where the epidermis fits into the skin. Okay, right. So basically, the epidermis is the outermost layer of the skin. It is the epithelium of the skin. Okay, so let's draw this here. Right, so the skin is the largest organ of the body and it surrounds everything and holds you together, basically. Okay, it's what stops water from evaporating from the bodily fluids out into the environment. Okay, it also makes you waterproof. It stops other fluids from the external world just gaining access to the body. It also plays an extremely important part in protecting the bodily fluids from pathogenic infections, because clearly if they're going to get into the body they have to pass through the skin, and it is a physical barrier to them. Okay, right, so the above is the external world and this is the outermost margin of the skin. Now, what I'd like to draw in my picture is, I'd like to have a hair follicle here, so I'm going to have a hair follicle here, but I'll come back and finish that in a moment. Okay, right, so the epidermis then is what's known as a stratified epithelium. Okay, and what this means is that it is multi-layered. Okay, that's what stratified here means. Stratified means that it's not just one layer of cells. A simple epithelium, okay, so let's contrast a stratified epithelium to a simple epithelium. A simple epithelium is an epithelium where you have one cell making up the entire layer of that epithelium. Okay, so epithelia are surfaces which line the outside of the body, basically. So, for instance, the skin is a major epithelium, but you've also got the linings of the gastrointestinal tract, the linings of the respiratory tract, the linings of the urogenital tract. All of these are epithelia as well, because they are also the outer boundary of your body, basically. Okay, now some of those will be simple epithelia rather than stratified epithelia, because the epithelium will be a single layer of cells, whereas in the case of the skin, the epidermis is multiple layers, basically, so it's a stratified epithelium. Okay, so it's not just one cell thick, the epidermis is multiple cells thick. Okay, right, so let's have the underside of the epidermis here. Okay, now the underside of the epidermis is not just flat. Instead, you have a number of these wave-like structures here. Okay, so the epidermis evaginates downwards, and the layer below also evaginates upwards. Okay, now these structures are known as Ricci ridges and Ricci pegs. Okay, so let me get this right. So basically, the name for one of these portions of the epidermis, okay, here, which I'm highlighting in red, which is evaginating downwards, okay, that's called a Ricci peg. Okay, so this is a Ricci peg. Okay, whereas the name for one of these evaginations from the under layer, which is known as the dermis, which is coming upwards here, this is known as a Ricci ridge. Okay, and the Ricci ridges and the Ricci pegs are complementary, as shown. Okay, so the epidermis and the dermis sort of slot together in this nice complementary way. Okay, so, oops, what am I doing here? This is a Ricci ridge that we've got here. Okay, right. So that's the boundary of the epidermis with the dermis then below. So all of this here, this entire layer, which has these Ricci pegs, moving into the dermis, and those are intercalated, as it were, with the Ricci ridges that are coming up from the dermis. This entire layer here is the epidermis. Okay, right. So obviously we'll come back to that, but now let's have a look at some other structures that are part of the skin that are not just the epidermis. Okay, so let's extend our hair follicle here. Okay, so basically the epidermis is going to invaginate downwards in a hair follicle. Okay, like so. And as you get to the base of the hair follicle, what's going to happen is it's going to bulge out like so. Okay, and this region is in fact called the bulge. And it narrows towards the inner bit, and then it will be continuous with the epidermis over here. Okay, so here is the epidermis continuing on over here. Okay, so one of these structures where you have this hair follicle invaginating into the skin, this is known as a pilosebaceous unit. Okay, and it's called that because it's not just a structure with a hair in. Okay, the pilo refers to the follicle with the hair sitting in it, which we haven't drawn yet, but it's also got sebaceous glands that are going to feed into this follicle that we have here. Okay, so that's why it's called a pilosebaceous unit. Okay, right, and I'd like to talk about the different sections of the pilosebaceous unit. Okay, so we'll start off with this outermost section here. So the portion that is continuous with the rest of the epidermis here. Okay, so this portion that I'm colouring in green, which is the entrance to the hair follicle here, or the pilosebaceous unit, this is known as the infundibulum of the pilosebaceous unit. Okay, so infundibulum means funnel. Okay, so basically this is like a funnel because we're funneling down into the pilosebaceous unit, the depths of the pilosebaceous unit. Okay, then the next portion here, the middle portion, where you can see I've tried to show it narrowing. It's better shown on this side maybe. Okay, but this portion which is a little bit narrower here, this is known as the isthmus. Now an isthmus means a narrowing basically. So if you imagine a dumbbell, the section in the middle of the dumbbell is much narrower than the portions on either side. That's known as the isthmus of the dumbbell. Okay, so this is called the isthmus here of the pilosebaceous unit. Okay, let's try colour coding this. We've shown the isthmus in blue, we've shown the infundibulum in green there. Okay, right. Then underneath the infundibulum, underneath the isthmus, you then have the bulge. So further past the isthmus down here, which I'm now colouring in yellow, this is the bulge, and then right at the base of the bulge, you're then going to have the portion that is actually going to give rise to the hair itself. Okay, so first, before we get to that portion then, we've got the bulge of the pilosebaceous unit here, and I've shown the bulge of the pilosebaceous unit in yellow. Okay, finally then, the portion right at the base of the pilosebaceous unit, which I'm now colouring in vivid purple here. Okay, this portion is known as the hair germ. Okay, and this is the portion that's actually going to produce the hair. Okay, right, so this is the hair germ. Okay, and now let's draw the hair within the hair follicle here, or the pilosebaceous unit. Now, how am I going to show this? I'll just have to go through there. Okay, so here is the hair, and it will be filling up all of that intermediate space here. So let's colour it in orange. Okay, so here is our hair. Now, the fancy medical term for a hair, okay, is to call it a hair shaft. Okay, so if you hear anyone referring to a hair shaft, all it means is a fancy way of saying a hair, basically. Okay, so this is the hair shaft. Okay, right. Well, the difference between a hair and a hair shaft is that the hair shaft really is the portion that's beneath the surface of the skin, whereas the hair is the portion that's above the surface of the skin. But to all extents and purposes, this is a hair, basically. Okay, right. So here we have our hair shaft in our pilosebaceous unit here. Okay, right. Now, we've shown the portion that pertains to the hair here, but we now haven't shown the sebaceous portion of the pilosebaceous unit. So, let's now put the sebaceous gland in here. So basically, the sebaceous gland is going to sit off the side like so. Okay, and I'll put it here. And I'll colour the sebaceous gland in red. And basically, the sebaceous gland continuously produces cells. Okay, so there are stem cells in the sebaceous gland, okay, which will be dividing and differentiating into new cells. Okay, and these cells will produce a huge amount of lipid molecules. They'll fill up with lipid, and then what happens is they burst and release the lipid into the hair follicle here. Okay, and this lipid which they release is known as sebum. Okay, and the sebum is going to help lubricate the hair, and also it's going to go onto the surface of the skin and basically functions as your natural moisturizer, basically. Okay, so in red there we have the sebaceous gland, so I'll colour code this label down here in red. So there's the sebaceous gland. Right, so that's the structure of a pilosebaceous unit. Now, the portion then of the epidermis that is not part of a pilosebaceous unit, so the portions that are in between the pilosebaceous units, and by the way, pilosebaceous units are often abbreviated as PSUs for short. Okay, the portion of the epidermis that is in between two pilosebaceous units, so the normal portions of the epidermis, this is actually known as interfollicular epidermis. Okay, because it's in between hair follicles. Okay, so if you want to specifically tell someone that you are talking about the epidermis that is not part of a hair follicle here, or the boundary of a hair follicle, the pilosebaceous unit, then you would call it the interfollicular epidermis. Okay, and it's the interfollicular epidermis that we are going to study in great detail in this video. Okay, right. Now, moving on with the structure of the skin then. Firstly, let's also finally finish up our pilosebaceous unit by putting the Erector Pili muscle on. Okay, so there is a muscle whose job it is to erect the hairs, basically. Okay, and you do this, for instance, when the environmental temperature is very, very cold. Okay, it's known as goosebumps. Goose pimples. Basically, when the temperature is very, very low, you want to trap a layer of air around the skin. What you certainly don't want is air flowing easily over the surface of the skin, because if you're constantly getting fresh, cold air onto the surface of the skin, it's going to take away heat much more effectively. So what you do is you erect all your hairs, okay, so that they resist the flow of air over the surface of the skin, and that reduces the exchange of heat from the skin to the surrounding ambient air. Okay, right. The muscle which does that then is a little muscle here. Okay, a little strip of muscle known as the Erector Pili muscle, which attaches to the underside of the epidermis somewhere up there. Okay, so I'll colour the Erector Pili muscle also in red here. Okay, so that's shown there. That's called the Erector Pili muscle, and its job is to erect the hairs, okay, in response to cold temperatures. Okay, so usually the hair will be sort of flat down like that, and then when this muscle contracts, obviously that's going to pull this in that direction, okay, and it will move like that so that the hair is erect. Okay, right. Now let's talk about some other portions of the skin then. So, the portion of the skin underneath the epidermis is known as the dermis. Okay, so I'll put the lower boundary of the dermis down here. So all of this portion here, from the bottom of the epidermis here, to this line that I've drawn down here, all of this is going to be the dermis, basically. So this is not an epithelium, okay? The epidermis is the epithelium of the skin, okay? The dermis is the layer underneath the epithelium of the skin, basically, underneath the epidermis. Okay, right. So epidermis, and now we've got the dermis. Okay, so what is the dermis? Well, the dermis is a layer of connective tissue, basically, okay? And in the dermis, you have all sorts of fancy structures. So, for instance, you will have sweat glands, which we're not going to show here. You will have nerves. You will have blood vessels, okay? You'll have lymphatic vessels, all sorts of things, basically. Okay, so then underneath the dermis, you then have a layer known as the hypodermis, okay, which is also sometimes called the subcutaneous fat layer. Okay, so this layer underneath the dermis then, this is known as the hypodermis, or more often it's just called the subcutaneous fat layer. Okay, now the reason it's called that is because it contains a large number of adipocytes, basically. Okay, so there are a lot of fat cells here, white adipose tissue. Okay, right, so this is the hypodermis or the subcutaneous fat layer. All of this layer here. Okay, right, now in this layer, amongst the many adipocytes, so I'll draw some adipocytes here. So let's say these are a few adipocytes here, and I'll colour them in yellow. Amongst the adipocytes, you are going to have large arterioles and venules flowing. Okay, so we've got a large arteriole here in red, and a large venule here in blue. Okay, and then what will happen is these will give off smaller branches, smaller little arterioles, which will move up into the dermis. Okay, now they do not get into the epidermis. You don't have blood vessels in the epidermis. The epidermis is avascular. Okay, but you form a very rich capillary bed just underneath the epidermis so that nutrients can move by diffusion into the epidermis. Okay, and then we'll show a small little venule here, collecting the blood back from the capillaries and then taking it down to this larger venule in the hypodermis or the subcutaneous fat layer down here. Okay, right, so that's where the blood vessels are. You have the large arterioles, and I'll just label these up. Okay, so this large red vessel here, this represents a large arteriole, and this large blue vessel, this represents a large venule. And they're both giving off smaller branches, which are then going up into the dermis. Okay, right, then underneath the hypodermis or the subcutaneous fat layer, what you then have is a layer of very tough connective tissue. Okay, so I'll put this here. So this is known as the deep connective tissue, okay, of the skin. Okay, and then underneath this deep connective tissue of the skin, what you'll then have is the beginning of the muscle layers. Okay, so for instance, if we're talking about the abdomen, you'll then, underneath this deep connective tissue, you'll have the oblique muscles, basically. Okay, the muscles of the abdominal wall. Right, so we'll colour in this deep connective tissue here in blue. Now there is one last little thing I'd like to talk about, which is the fact that we have these two connective tissue layers. We have the dermis, which is a connective tissue layer here. So all of this space, this is full of connective tissue, basically. Then we have this layer of fatty bloop, basically, and then we have another layer of connective tissue. Now, this isn't very rigid. This gloopy layer isn't very rigid, but the two connective tissue layers are very rigid. So what, in fact, you have is you have connections that move through the hypodermis from the dermis to this deep connective tissue layer down here. Okay, and these are helping to stabilize the structure of the skin, okay, because they connect these two connective tissue layers. They connect the dermis, which is this layer of connective tissue, to this deep connective tissue layer, okay, and thereby they hold the structure rigidly together. Okay, so what are the names for these connective tissue connections that run between the connective tissue of the dermis and the deep connective tissue underneath the hypodermis? Well, these are known as skin ligaments. Okay, so you have these little strands of very rigid connective tissue that stretch between the dermis and the deep connective tissue, and thereby attach these two layers together, and that helps to rigidify the skin. Okay, it means that this layer is actually attached to this layer, even though it's got this gloopy subcutaneous fat layer in between the two of them. Okay, right, so that's the structure now of the skin. So that gives us the big picture of where the epidermis sits within the skin. Okay, so we are now going to study the epidermis in more detail. Specifically, we're going to study the structure of the interfollicular epidermis, which, remember, is the epidermis in between two pilosebaceous units. So we're not going to study the pilosebaceous unit in any more detail than what we've said about it already. We're going to study the interfollicular epidermis. Okay, right. So, where are we going to begin then? Well, we're going to begin with the bottommost layer of the epidermis. Okay, now, the bottommost layer of the epidermis is a basement membrane, and in fact, all epithelia sit on a basement membrane. Okay, so this isn't just something fancy for the epidermis. Absolutely all epithelia you can think of have one of these basement membranes. Okay, so let me show you on this picture what we're talking about. So basically, right at the base of the epidermis, before we've got to any of the cells of the epidermis, you have a structure on which all of the cells of the epidermis are sitting, basically. Okay, they're all piled on top of this structure. Okay, and this bottommost structure, now shown in turquoise here, this is the basement membrane, or the BM for short. So let's now discuss the structure of the basement membrane. Okay, right. So the first thing I want to say is that the basement membrane has another name. Okay, it's also known as the basal lamina. Okay, right. The next thing I want to say is that you can divide the basement membrane up into two separate layers. So let's draw a picture here. So we're discussing the epidermis specifically. So I'm going to show the the Ricci ridges and the Ricci pegs, basically. So remember, the Ricci pegs are these extensions of the epidermis downwards, and the Ricci ridges are the extensions of the dermis upwards. Okay, right, so here we go. Okay, and then we've got the basement membrane, this bottommost layer on which all the cells are sitting, basically. And we can divide this basement membrane up into two layers, which is what I'm going to do now. Okay, right. So here are the two separate layers of the basement membrane. And this is a little bit of an over-exaggeration. It wouldn't be quite so big in reality, okay? It's a very little thin structure. Right, okay, so two layers, okay, and one layer is going to face down towards the dermis. Okay, so I'll colour this layer that's facing down towards the dermis in vivid purple here. Okay, this layer is known as the lamina densa. Okay, and it's called that because when you look at it down the electron microscope, it looks more dense and dark than the layer above it, which is known as the lamina lucida. Okay, so here we have the lamina densa of the basement membrane in vivid purple here. Okay, right, now let's colour in the other layer, which is the one that's facing the actual bottommost cells of the epidermis itself. Okay, and this layer I'm now colouring in blue, and this layer is called the lamina lucida, which contrasts it with the lamina densa. Okay, so this layer is much less dark when you look at it down the electron microscope. Okay, so in blue here, this is the lamina lucida, and these two two separate layers of the basement membrane or the basal lamina, these are consistent for all epithelia. So this isn't just the skin that has one of these. All epithelia have this same structure at their base, and it always has these two separate layers of lamina lucida and lamina densa. Okay, right, so we're going to start by discussing lamina lucida, and this is the layer that's going to connect to the basal keratinocytes here. Okay, so I'm now showing the bottommost layer of cells of the epidermis. Okay, so let's introduce this bottommost layer of the cells of the epidermis. We're not going to discuss this right now. We're going to firstly discuss the basement membrane, but I think it's worth putting this here because we need to discuss the fact that the lamina lucida is going to connect to this basal layer of cells of the epidermis. Okay, so these cells that are sitting on top of the basement membrane and are the utter basal layer of the epidermis. So remember, the epidermis is this stratified epithelium, so it's got cells piled above this basically, but these are the ones that are actually attached to the basement membrane. These are known as the basal keratinocytes. Okay, now what is meant by a keratinocyte? Well, basically all the cells of the epidermis are referred to as keratinocytes. Why? Well, it's because they all synthesize keratin, okay? And we will come back to keratin later, okay? That's going to be very, very important that these cells have a lot of keratin in. Okay, so the name for this bottommost layer of cells of the epidermis that consists of these basal keratinocytes then is known as stratum basale. Okay, now stratum just means layer. Okay, basal means that it's, at the base. Okay, it's got another layer, another name as well. Okay, it's also known as stratum germinavitum. Okay. Probably slightly more rare to hear it called stratum germinavitum than it is to hear it called stratum basale. This refers to the fact that these cells that are the basal layer of keratinocytes, these are the ones which are actually going to be dividing and therefore are going to be producing all the other cells above it. Okay, so that's where this long word germinavitum comes from. Okay, they are the cells which germinate the other cells of the epidermis and are responsible for this continuous renewal of the cells of the epidermis.